Today we'll be getting started with Gin and Vue.js. So let's say you just picked up Golang and you got decent at the language. And next thing you do is go out and search for a backend framework with Golang. And you stumble upon Gin. You are a passionate web developer and you decide to build a full stack application using Gin as the backend and your favorite front-end framework, which in this case is Vue. Today we'll be building a CRUD application using these three technologies together with a few others. So let's say you use a broker to invest in the stock market, and this broker hasn't updated their user interface in like 20 years. So you decided to go out and build yourself a portfolio tracker. Well, this is what we're going to do in this video. We're going to build the minimum required functionality for a brokerage account. Now let's talk about the Golang backend architecture. We're going to be implementing a layered architecture with 4 layers. The first layer is going to be the controller layer. This is where we're going to define our API endpoint, and this layer is going to call the service layer. Here, the business logic of our application is going to be handled. And this service layer is going to sometimes make a connection to the repository layer, and in the repository layer we're going to define our database interactions. Now the repository layer is going to be dependent on our data storage. So for example, we're going to have a Postgres instance or perhaps a Redis one, or even interact with the cloud, for example AWS or Google Cloud. And here separated we're going to have a entities layer. This is where our data is going to be defined, and the data that is going to be stored in our data storage, but also the data that is going to be passed from one layer to another. As you can see here, right here, this is the call flow. So our request comes into our API endpoint and travels up to the Postgres instance, and this is our dependency flow. If our data storage instance goes down, everything is compromised. Now let's jump into Visual Studio Code. As I've said, we're going to build a stock portfolio tracker tool, and in order to do that, we're going to need to manipulate our transactions on the stock market. So we're going to begin by defining a Docker Compose file, and if you are unfamiliar to Docker, I recommend you check out my Introduction to Docker playlist. And here we're going to define our services. And I'm going to begin by defining our reverse proxy. In this case, I'm going to use traffic, and if you're unfamiliar to traffic, I guess you can use perhaps something else like Nginx. But here we're going to define our configuration for the traffic reverse proxy, and we're going to say that we want to use Docker, and we don't want traffic to detect all containers on our network. I want to specify manually which containers traffic can see. And we're going to expose both the traffic dashboard as well as our application. This volume is required by traffic in order to work. Next, we're going to define our Go app. And I'm going to paste this code right here, because I'm sure you don't want to see me type all this code. We're going to define our Go app, and we're going to build it from a source directory with an image of Go app. I've noticed that you have to add this directive because without it, traffic won't be able to see or route this container for some reason. So you better define this image for your container. Next, we're going to expose our application, and we're going to set up our configuration. We're going to enable traffic to see this container, and we're going to route this container to this IP address with a prefix of /API. So all of our calls are going to be made on the /API interface URL. And we're also going to enable load balancer on our application. we're going to define an environment file, which we're going to create a little bit later. And this, I've added this so I can have hot reload. So basically when I make a change in my code, Docker is going to rebuild our application instantly, and I don't have to run docker compose down and docker compose up slash dash dash build. And one last thing that we're going to define is, of course, our depends on. So I want to add depends on, and I'm going to say reverse proxy, and as well as Postgres. So now we're going to define our Postgres instance, right? And this is the database I'm going to use in this tutorial to store our transactions. So here is the Postgres configuration. We're going to use an Alpine image, and we're going to set the Postgres password from our environment file that we're going to create in a short while. And we're going to bind the port, as well as we're going to create a schema.sql script to create our table, because I've decided I don't want to use migrations for this project. I'm just going to run a SQL script. And we're going, of course, to save our PG data in a volume and run this command to run our container. Now I'm going to define the volumes. And this is basically so that Postgres data isn't lost when I tear down this container. Great. Now let's create a .env file. Here we're going to store our Postgres variables. These are the default values for Postgres, and you have to be careful that this PG host corresponds to the Postgres service name. Next, I want to copy in the schema.sql file, and in this file we're going to basically create the transactions table. Next, I want to create a source folder. In this source folder we're going to have our Gin app. So let's run go mod init, and we're going to say Gin Vue, we're going to call it portfolio tracker. Right. And let's add the main.go file. And in this, now I want to add some of our dependencies. So the first thing we're going to do is going to add our Gin Golang application. So go get Gin Golang, and it's going to take a while to pull the dependencies. Now we're going to bring in the SQLX driver, and this driver is we're going to use it to interact with our Postgres application. And of course we're going to bring a driver for Postgres. Okay, now we have everything set up. We can write package main, and here we're going to write our first Gin router. Okay, so let's type func main, and here we're going to bring in a log statement. The parentheses, we're going to log starting server, and we're going to initialize our router, which is going to be of type gin.default. The Gin default method returns an engine instance with the logger and recover middleware attached. Now, for this episode, the middlewares are out of our scope, but I do recommend you go and check them out in the docs. And next thing we're going to do is basically we're going to define our server. So our server is going to serve on port 8080, and it's going to take the router as a handler. And we're going to now listen and serve on our server. Next, I'm going to add a graceful server shutdown. You can find this code on the internet. And what basically this code does, if we send a SIGINT or a sync term signal to our application, is going to close it. It's not going to brutally close it. It's going to take a 5 seconds timeout. And so the next thing I want to do is instantiate our database. So I'm going to create a initdb-go file, and in the initdb-go I'm going to basically define a struct and go to write package main, of course, first time, and I'm going to define a db construct that is going to take a sqlx -db instance. Now I want to write a func initdb, and we're going to log that we're initializing the Postgres database, and I want to fetch from the env file our environment variables for the Postgres database. Next, I'm going to bring in a pgcon string, where we're basically going to take all these variables and put them in a string. And next, we're going to try to connect to the Postgres application. So now we're going to paste this in. So connecting to Postgres, we're trying to open a connection to Postgres, and if it fails, we're going to send error and nil. If everything is alright though, we're going to return a DB connection to the main file. And of course, we also have to write one more function, and this function is going to be used to close our connection to the Postgres instance, and we're basically trying to close the connection. If we get an error, we send it back, else we're going to return nil. Right now that we have our database initiated, we're going to import it in our main file. We're going to say db error initdb, and a little bit down, I want to, right here, I want to close just before the server ends. I want to close our application. And of course, we want to handle the error in case we actually get an error from initdb function. Nice. Next, let's start working on our layers. I want to start by adding a entity layer. So I'm going to type entity, and here I'm going to create a transaction.go file. Here I'm going to write package entity, and I'm going to bring in a struct. So a struct of type transaction. Right here we can see we have the fields defined for our transaction, and under these quotes we have a few tags. We have the db tag, and this db tag is basically going to represent a column in our database. If we go to the schema.sql, we have right here the ID, the type, the ticker, and they correspond to the symbol right here. And we also have a JSON tag. And basically this, if we get a JSON object that should be of type transaction, we'll be able to bind that object to our struct using these tags right here. Also, you can see that we have this binding tag, and this is basically going to define some rules that validates our input. So for example, we can make a field required in the struct, as well as we can say that this string should be, the length of this string should be greater than 2 and less greater than 5. Next, I want to start working on the layers in order of the dependency flow. So let's start by adding in the source directory a repository directory, and here we're going to add a pg underscore transaction.go file. PG comes from Postgres. Here we're going to say package repository, and I'm going to bring in a interface. This transaction interface is going to define the methods that we're going to use to work with the database. Now I should tell you that you may see this interface right here separated in the entity folder, but I like to have the interface right here in the repository layer, because I like to see at the beginning of the file what methods are defined in that particular file. So we're going to create a struct, and we're going to create a new factory. This factory is going to implement our transaction repository. So now let's implement these four methods. If we look at the error, we can see that this new transaction repository is missing this method. So let's start by adding the find all method, right? And this find all method is going to take a context of type context, and it's going to return an entity transaction, a slice of entities transaction, or an error. We basically querying the database for all transactions, and we're returning these transactions to the upper layer, to the service layer. Next, let's look at the add method. Right here we can see we receive a context as well as a entity transaction variable, and we're basically going to insert this entity transaction into our database using the query row, which now we have a couple other methods. The edit method, of course. This edit method is a little bit more interesting, I think, because we're going to update the transactions with the new data where the ID is equal to the entity transaction that we want to modify. And of course, the last function that we are going to look at is the delete function. This is a very easy function. We're going to delete the transaction with a certain ID. So now let's build the service layer. So we're going to build a new folder, service. I'm going to say transaction service.go file. And here we're going to say package service. And of course, we're going to implement the interface as well as the struct. And right here we can see the dependency injection I was talking earlier. In the service, we're basically instantiating a transaction repository, while in the transaction repository, we're basically instantiating a DB connection. And you can see right here, let me just paste this in. I'm building this transaction service struct with a small letter, because I don't want it to be available unless you're using the factory method. And have a new transaction service factory, and again returning this interface. So as you can see right here, again we're missing the methods. So let me just paste them in, and this time I'm going to paste them in all at once. We're going to look at them. So the find all is very simple. We're just going to call the repository find all method, and we're going to return them to the controller layer. Now again, with the add, we're basically doing the same thing, and right here with the edit and the delete, we're basically doing the same thing. Usually in this layer you would handle the business logic, but we don't have that much business logic. We're basically building a small CRUD application. Perhaps you can do some validation right here, but we're going to keep it simple, and we're going to move on to the controller layer. Now let's go ahead and build what is probably the most interesting layer, and that is the controller layer. And right here we're going to create controller.go. We're going to say package controller. Right here we're going to build to add the controller struct, and this is going to be a little bit different. This far we have initialized this struct using the function parameters, but this time I'm going to actually add a config struct. So we're going to pass this config struct to the new controller function, and right here we can see we add the transaction service, as well as we're going to pass the Gin engine. So let's go ahead and build the new controller factory, and this is going to be a little bit different. Again, we're going to create our controller, and now we're also going to define our API endpoint. So using the Gin router, we're going to define our API route, and they're going to start with a /API. So now let's define these routes. So let's pass them in, and we're going to have an API endpoint for each operation, and we're going to pass the route as well as a method of our controller. And we of course have to define these methods. So let's go ahead and build them. I'm going to bring them in real quick. So first of all, we can see right here we have the find all transactions, which is going to take a Gin context. We're going to get the transactions from our transaction service, and of course we're going to pass to this function a context.context. So basically right here we're converting the Gin context to a context.context. If we're getting an error, we're going to throw a internal server error. If not, we're going to return a status OK. And let's go ahead and now look at the add transaction. Right here, it's a little bit different. We're going to try and bind the incoming request to our transaction struct right here. And if we get any errors because of our binding, we're going to say status bad request and throw the error. Otherwise, we're going to call the transaction service, and we're basically passing the transaction as well as the context. If we get an error, again, we're going to throw the 500 as well as the error. And if everything is all right, we're going to say status created and a message. Now let's go ahead and look at the edit transaction. Again, very similar. We're binding the JSON to our transaction. If it doesn't work, we're going to say that it's a bad request, and we're going to call the transaction service. If again we get an error, we throw a 500. If not, we are going to say status accepted. And right here, we're going to do something a little bit different. We're going to define a request, because as we know, the transaction service only expects a int and not the entity, the transaction. So we're basically going to create a custom request with a field of type int, and we're going to try to bind that request to this definition. Again, if we get an error, we're going to say bad request. If we get an error calling the delete method from the transaction service, we're going to throw a 500 error. And if everything works, we're going to finally throw a status accepted, and we're going to say that we have successfully deleted the transaction. Now the last thing we have to do is to inject our dependencies. So we're going to go to main.go, and right here we see that we instantiate our database, and as we know, we have to instantiate the transaction repository using a DB connection. So right here under Gin default, I'm going to instantiate the transaction repository with a db.db instance. And again, I'm going to do the same with a transaction service. I'm going to instantiate the transaction service using the transaction repository. And finally, we're going to instantiate the controller. We're going to say controller.new controller. We're going to pass the router as well as the transaction service. Finally, it's time to build a Docker file for our application. So let's go ahead and type Docker file. And right here, I'm going to copy this Docker file. We're basically pulling the Golang image, and we are going to get the go mod and go sum files and download the dependencies. Then we're going to copy the source code and build it. And we're going to create an Alpine container, and we're going to run our application in this Alpine container with .run. And the last thing we have to do is actually build the application. So type docker compose app -- build and build the application. And we can see right here, we're getting an error, unable to initialize DB. Forgotten import. Oh, actually there's an interesting thing right here. If we go to initdb, this SQLX driver is actually dependent on the Postgres driver, so you have to import them. Apparently Visual Studio didn't import it automatically, so you'll have to import it manually, and you'll have to use this underscore to tell the Golang that this is dependent on this library. So now if we recreate the container, you can see right here that we have our endpoints. Finally, let's go ahead and test these endpoints. I'm going to run some curl commands, and the first command is going to be curl get. You're going to see that the transactions are currently empty. There's no transactions. And I'm trying to add a transaction. And we can see message added successfully. If we get the transactions, we can see the transaction right here. Next, let's try and edit the transaction. As you can see right here, we are changing the volume. So let's go ahead and we can see edited successfully. We can see that change right here. And finally, let's go ahead and delete this transaction. And delete it successfully. So our API endpoints are working. Next time, we'll be building the Vue frontend.